Probability of compound events in general means that two things are happening. And what is the probability of perhaps two things coming together? There are two types of compound events when we're talking about probability. The first is independent events. The second is dependent events. Looking at independent events, those are events that don't have any effect on each other. The rule to calculate that type of probability is quite straightforward. The probability of event A happening and event B happening is simply the product of the two separate probabilities. Here's an example. We're supposed to find the probability of rolling a 3 and then rolling a 5. The probability of rolling a 3 on a die would be 1 out of 6. The probability of rolling a 5 on a die would also be 1 out of 6. So the probability of rolling a 3 and a 5 would be 1 time out of 36. So the key here is to identify independent events. Rolling one die has nothing to do with rolling the second one. Here's a sub-example of independent events. It's called choosing with replacement. Give this list of numbers. Let's look at it. I'm supposed to pick a letter and then replace it and then pick another. What is the probability that you pick a D and then pick an A? The key here is that we're choosing with replacement. So the denominator of possible outcomes won't change. My probability of picking an A is 4, if you count them up, out of 10 options, total outcomes. Because I'm putting that letter A back into my list to choose from, my probability outcomes for B is still 10, but I only have one B. So let me go over that again. The probability of choosing an A from this list is 4 out of 10. The probability of picking a B is 1 out of 10 because I replaced the original A. Multiplying these probabilities together, you get 4 out of 100, or 1 out of 25. Let's have you try these two guided practice problems using independent events and probability. Pause the video now. I just wrote the problems out first and I will discuss the answers. So in the first problem, you're rolling 2 dice. That's definitely independent events. The probability of rolling an odd number on the dice would be 3 out of 6 total outcomes. And the probability of rolling a multiple of 3 would be 2. There's 2 options of rolling a multiple of 3 on the dice, and that would be 3 and 6. Multiplying those two together, you get 6 out of 36, or a final answer of 1 out of 6 when you reduce. In number 2, suppose you have 3 quarters and 5 dimes, and we're looking for the probability that you pick out a dime and then a quarter. And this is with replacement. You're putting the coin back. The probability of picking a dime would be 5, because there's 5 dimes out of 8 total coins. And the probability of a quarter would be 3, because there's 3 quarters out of 8 total coins. And the key here is you still have 8 possible outcomes because you put that dime back in. And then when you multiply that, you get 15 over 64, which is in simplest form. Now let's move to dependent events. Dependent events are events that influence each other. They have an effect on each other. And here's how you would write the rule for dependent events. If you were looking for the probability of an event A and then an event B, you would take the probability of event A times the probability of B after A happened. So you're going to want to write these two big rules down. This one for dependent events and definitely the one for independent events. Here's an example. You're picking lab partners. What is the probability of picking Sue and then picking Mike? Well, we would write out the probability of that as the probability that Sue gets picked times the probability that Mike gets picked after Sue. So let's start with the probability of picking Sue. There's 4 partner options here. And if you pick Sue, that probability is 1 out of 4 options. But now that Sue is picked, she's taken out of the possible outcomes. So our possible outcomes is now down to 3 for the second event. Picking Mike after Sue, that probability is now 1 out of 3. So the key here is your denominator changes in the second event. And then you will go ahead and multiply, and you get 1 out of 12 would be the probability that that combination would take place. This brings us to our sub-example of probability of dependent events, and that's choosing without replacement. Because we do something in the first event and don't replace it back into the list of options, you are affecting the probability of the second outcome. Here's an example. Here we're picking a letter, but this time we are not replacing it, and then we're going to pick another letter. So the question is, what is the probability of picking A and then B without replacement of that original A? Well, the probability of picking A is the same as it was in the other example. There are 4 A's in the list out of 10 possible letters. But now that A is held onto and not put back into our list of options for the second round. Because of that, I only have 9 possible outcomes. And I still only have 1 B. So that's how you'd write the ratio of probability for the second event. Then you go ahead and multiply, and you get 4 out of 90. That can be reduced to 2 out of 45. The key here is to note that the denominator changes in the second ratio. Here are a couple more examples of dependent events and not replacing the letters. The probability of picking C and then B equals the probability of C times the probability of picking up B after C was picked and not replaced. The probability of picking C in this case is 3. I have 1, 2, 3 C's. And I still have 10 options. The probability of picking B after that by not replacing my C's, my 1 C that I picked, you have now 9 options for an outcome. And we only have 1 letter? No. Yes, 1 letter B. So then when you multiply that, you're going to get 3 out of 90, which can be reduced to 1 out of 30. You try this second example. Pause the video. Perhaps this one requires you to think just a little bit harder. We start off with our probability of picking a C, and we had 1, 2, 3 of them out of 10 options, so this one was pretty straightforward. But the probability of picking another C after you've already picked one changes. Because you picked 1 C out, your only options of picking C now are these 2, 1, 2. But because you did not replace this C, it's totally gone, your total number of outcomes for the second event is only 9. Here are 2 more guided practice problems. Make sure you're reading the paragraphs to decide if something's being replaced back into the set or if it's being taken out. Pause the video now. Dig into what those answers look like. It's also important that you're writing these lines right here because that is the equation that you're using. Let us know if you have any questions, and remember you can always watch these videos again, because if this is the first time you're seeing this, it can be a little uncomfortable. Thanks for watching.